Okay, so using lenses. When we use lenses, the image that we make depends on two things. One is three things. One is the size of the lens, so how powerful the lens is. One is how far away the object is. And the third one is whether it's a concave or a convex lens. So to start with, I'm going to do the convex lenses. So the more powerful the lens, the shorter the focal length is. Okay, so remember the focal length is the distance from the lens to the principal focus, or f. So I'm going to put an object here, and I'm going to say that my object O, and I'm going to put my object right in the middle of this lens. And I'm going to say that the focal length is here, and I'm going to say that 2f is here, so twice the focal length. So my object is further away than two lots of the focal length. Okay, I then want to draw a line from the top of my object. So let's say that I have a candle here, or a match or something like that. That's my object. Okay. I draw a line from the top of my object, parallel with the line through the centre. So you draw a line straight through the centre of the lens. You draw a line parallel to that, and whatever the focal length of the lens is, you draw a line that goes through the principal focus from this one up here. Okay. You then take a line straight through the middle of the lens, like so, and you then, this would then be, sorry, probably drawing it freehand. Okay, and then where these two lines cross, that's where the image is, and it's not to scale. But what you need to know is that because the object is outside, because the object is a greater distance, so the object distance is greater than 2f, it would mean that this, so it means that the image is smaller than the object, which makes sense, because if you think about something that's really far away, like the moon for example, you could use a telescope. Your moon is clearly further away than 2f, so your image of your moon is much smaller than the moon itself is. Okay, that's what it's saying. It's saying that the object is further than 2f, so therefore the image is going to be smaller than the object, and we call that diminished. You'll also notice that it is now upside down, so we said it is inverted. The lens in your eye makes the image inverted, so on your retina the image is upside down, but then your brain's very clever and it flips it the other way around. If you wear glasses that flip it before it goes into your eye, into your retina, and you wear them for a couple of days, so you see the world upside down for a couple of days, your brain will flip it back the other way, so you'll think that up is down and down is up. There's an experiment that people did to that, and then you take the glasses off and it reverses again, and now you think that down is up and up is down. Look it up, it's really, really crazy. Okay, so next one is what happens if the object is much closer. Okay, so what happens if the object is much closer? If the object is much, much closer, then you're going to get something else happen. So let's draw my lens again. Let's draw my line through the middle. And let's put my object here this time. And this time I'm going to say that's my f there. So this time I'm closer than F. It's not quite this. Okay. So exactly the same process. You draw a line from the top, and you go through F, and you draw a line through the middle. These lines are never going to meet. But your brain can't cope with that. See, what your brain says is, well, if I'm here, I reckon that this line must have come from over here. So it traces it back and it says it must have come from over here. Because light has to travel in a straight line. And it takes it back. And then if you take both lines back to where they meet, you get a person here. And you can see that one has been magnified. And if this is the image height, and this is, sorry, if that's the image height, and that's the object height, then the magnification is simply image height divided by object height. And if it's diminished, it'll be a decimal, and if it's magnified, it'll be times so many. Okay, that is how a magnifying glass works. It's got a nice long F, so you can put an object within the distance. You get it nice and close to it, it will then magnify it. Okay, that's how magnifying glass works. Okay, so the next one you need to know about is divergent lens, so concave lens. Exactly the same process. We've got a person, we've got a concave lens, we draw a line, we draw a line through the middle of the lens. We'll say that the object is outside of F. Put F there. Draw a line from the top into the lens. It will then get diverted, but we know that it should have gone through F, so we'll divert it, and then we'll draw it backwards like that, and we'll draw a line through the middle of the lens. Straight through the middle of the lens again. So therefore, where those two lines meet, will give you the image here, and that would be virtual. Anything with a dotted line, see these have got dotted lines. Anything which has got a dotted line, so dotted equals virtual. Because what your brain is saying is, oh, it must have come from there because light travels in a straight line, but it hasn't really. Okay, your brain just thinks it has. So that's a virtual image. This one's not inverted, so that one's right way up. It's diminished. Now you can describe any form of image by lens